Hi, you guys. For our question of the day today, hopefully you're doing this pre-test because this is going to be helpful, or pre-quiz, sorry. So let's look at our question. So it's giving us an equilibrium equation, and it's saying if 0.25 moles of the Br2 and 0.55 moles of Cl2 are introduced into a 3-liter container at 400 K, an equilibrium concentration of 0.12 molar is found for the Cl2. What is the Kc for this reaction, and then does it favor the reactants or products? So we're given a lot of different information. So we're given the moles of Br2 and the moles of Cl2, and we're told it's a 3-liter container. Remember, when we do the equilibrium expressions, we're doing those expressions in molarity, and so we need to get this to molarity. And then we're going to use an ice table. So let's look at this here. So first, I'm going to set up my ice table. So initial, change, and then at equilibrium. These are the values that we're going to put into our Kc expression. And our Kc expression is going to be products, BrCl squared, over reactants, Br2, and Cl2. Okay. Let's see. From here, I'm going to put my equation in. So I've got Br2, Cl2, and I like to put in my arrows just to kind of show me what's my reactants, what my products are, and then BrCl. So the first thing I'm going to do is with my initial concentrations, I'm going to find, or my initial amounts, I'm going to find concentrations. So for the Br2, I'm going to take 0.25 moles in the 3-liter container. So 0.25 divided by 3 gives me a molarity of 0.0833. And I'm going to do the same thing for my chlorine. I'm going to take the 0.55 moles in 3 liters. And that gives me 0.1833. Okay, so that's the first part of it. If it doesn't tell you that it put any of the product into the reaction, you can assume that we're going to start with none. And then it also tells us that at equilibrium, a concentration of 0.12 molar is found for my Cl2. Okay, so that there is going to be the most helpful piece, because now I know how much I started with, how much I ended with, and I can find how much of a change there was. So I'm going to take my initial 0.1833, and I'm going to subtract out my final, and that tells me that I had a change of 0.0633 molar. Now, if I want to find the change for the other things, I need to look at the stoichiometry. So when I go back up to my balanced equation, I see that the Br2 and the Cl2 are both 1s, which means it's 1-to-1. So if I lose 0.0633 of the Cl2, I'm also going to lose 0.0633 of my Br2. Now, my product is going to be made, and I also see that it is a 2, so that means it's double the amount. So I'm going to take my 0.0633, I'm going to multiply it by 2, and my BrCl2 is going to gain 0.1266 molar. So now I'm just going to go down the column and do my work. So I've got 0.0833 minus 0.0633 gives me 0.02. I've already got my Cl2, and then 0 plus 0.1266 is 0.1266. So now these values can be plugged into my equilibrium expression to find the Kc value. So Kc is equal to my BrCl is 0.1266, and that value needs to be squared. My Br2 is 0.02, and my Cl2 is 0.12. So when I plug this into my calculator, I am going to do, let's see, 0.02 times 0.12. So my denominator is 0.0024. And then I'm going to take my top, 0.12 0.66 squared, and then divided by my 0.0024, and I get a Kc value of 6.68. Okay, and remember Kc does not have a unit, so that is my answer. Now the question is, does it favor the reactants or products? So since Kc is greater than 1, I would say that it is going to favor the products. Now I want to check that with my work. So if it favors the products, that means that at equilibrium, it's going to have made more of the product than the reactant. So we can see that during this process, we did not lose a ton of our reactant, but we made quite a bit of products. We went from 0 to 0.122 versus our reactants being at a lower amount. So that makes sense to me. And you are good to start your quiz as long as you have completed all of the practice from last week. As always, let me know if you have any questions. Talk to you later.